So we will concentrate on most of the supervised learning as of now, because we know that we have these three types of learning: the supervised, unsupervised, and the reinforcement. So today we will see the supervised learning example of some supervised learning, and we will see some models and how to train a model and how to predict some result using different class of machine learning algorithms. So you see that the supervised learning is one of this most widely used algorithm in machine learning, and it has two classifications. This one of them is it can be this divided into two categories. One is the classification and another one is the regression. So we will see two types of programming today: one through this classification algorithm and another through this regression algorithm. So this what this classification algorithm is usually do. Just go to the straight to the things that classification is. It will classify the algorithm. Suppose we want to detect. We will see the one example: this diabetic prediction using machine learning algorithm, whether a patient is diabetic or not. So this is an example of this classification. We'll also see some this rock versus mine prediction. So we will say go through this example, and we will see that how this classification is used. So classification is used to return some discrete values, either whether it's a true or false, or whether it is this diabetic or non-diabetic. So this type of things this concentrates the domain of classification. Whereas in regression, and regression is about predicting some continuous values. So you want to know predict the gold price, or you want to know this house price. So these are type of things in which you need some continuous value. It may be a salary, it may be age, it may be price. So just like that. So today we will try to cover these three examples. The first one is this sonar. So this is a rock versus mine prediction. The second one is this diabetes prediction using this machine learning, where we will use this support vector machine algorithm. And the first one, we will use this logistic regression model. So you will see that this example. So using this logistic regression, how we will determine whether it is whether this particular feature is rock or mine. So that belongs to this classification problem. The second one is also a classification problem. So we want to determine whether a patient is diabetic and non-diabetic using these data sets. And the final one, you can see that is a house price prediction using this machine learning. And we have used this is a regression algorithm. We will use here the regression algorithm, and we will see that this XG boost regression we will use here. And we will we will see this second classification, that is a regression model over here, and where we will predict the price of house, and we will use some data set. So let's go to this first example. So the first one is this rock versus mine prediction. We know that. So suppose you have a situation. There is a war between two countries. You can consider. So one of the countries trying to attack this another country through this the submarine and the water route actually. So this sonar actually what is do? It's actually is present in this submarine. You see that it transmits and receives the same signal. So the signal will transmit and receive the sonar actually generate a signal, and it can detect some metal or some rock, and it will just get back some different frequency signal, and from that it will determine whether it is a rock or it is a mine. So that is the basic of this the problem. So we need to determine this either whether it is a rock or the mine, and we will see this workflow and how we will go through it one by one. So first one, you will see that in the input, this is the sonar data. So we have this .csv file with us, and we will get this. These are the input side. So after that, we will process the data, and this consists of this data pre-processing part. And after that, we will go through this trend test split. We will split the data after processing into a training part and a test part, and we will go through this, then apply this particular model, that is a logistic regression model. And so what has happened? So initially we will train this our model with this logistic regression model, and once it's got transferred to this it's a trained logistic model, then we will give some new data that will be the test data. So here will be the test data, and we will give this test data to this trained model, and we will see that whether this model can predict whether it is a rock or mine. And for this thing, we will use this Google Colab, because I know that there may be some system requirements. So I am not using particularly any other software at this moment. So that's Google has provided a open laboratory, that is a co-laboratory. So I am stopping sharing the screen. I'm going this directly to the Google Colab from here. So let's so this is so just type in the Google. It is a Google Colab laboratory. It will open. So you'll open like this Google Co-Laboratory. So we want a new notebook. So we will just click on this new notebook. So it will this is an untitled this is the interface of this Google Colab. So first of all, we will do that. This is our project one. And we have this rock versus mine prediction. This is our project title. And this is a Google Cloud server. So everything will happen through this Google Cloud server. So before that, we have to connect to this cloud. And here is the connect option. We will click on this connect. So it will connect to this particular Google Cloud, and you will see that it is connected. So here you have some particular RAM, this 12 GB RAM and 107 GB of space is there. So it's all provided from the Google server side, the Google Cloud server. So this is our this window for this today's project. So the Google Colab actually uses this Python as the basic of this programming language, and you can see that if you want to export this file, so it will be this in this IPYNB format, .IPYNB. So here you can do two things, that you can write code in Python, and also you can just give some text through this. So we will start our project using this. So since we have this sonar data, so let's check this data first. Yeah, so we have this data with us. So this is the, so can you see this what can I say, this Excel file, everyone? Hello? Yeah, so this is the Excel sheet. So here is the list of data you can see. So there are total, we have this 59 of these columns. This you can see this, these are this total number of data points as 208, something like that. So there is a 208 data over here. This is a small data size, and we have some near about this 60 columns. So these are all the features. You can see up to BH, from the column A and up to this BH. These are all the features, and the last column is the labels. So these are the R stands for the rock, and you can see that M stands for the mines. So this is the data actually. So we will now go to this Colab. Yes. So what we will do first, so we will upload this CSV file in this Google Cloud. For that, we will go to this folder section, and we can just right click on upload. And here is the sonar data rock mine. We just, yeah. So the thing is that every time you go for this, you have to re-upload this. Once you this is a runtime. Yeah. Yeah, so Zoom, so actually Zoom is not possible. The thing is that you go to this Colab. When you open this Colab, there is a folder section over here. And when you click on this folder section, you can upload from this icon, this upload icon, or you can just right click over here and see this upload section over here. So this is our first job to upload this CSV file over here. And next we will start doing this programming, this model we will see. So our first thing we have to the first job actually is to import the dependencies. So we will create. So we will go by this thing. So we will mention the title over here, and then we will proceed. Yeah. So that it will be it has some workflow so that anyone can understand after whatever we are doing. So the first our job is this importing the dependencies. So what we need over here, so this is a text place. You can input any type of text over here, and this is the coding place where you can write this code in Python. So for that we need this NumPy. We'll import pandas. And since we are using this machine learning model, so we have this sklearn, this scikit-learn from, we have to import this certain libraries from there. So one is the scikit-learn dot model selection. We will import the train test split function, this one, from sklearn linear model. We will import our model, that is the logistic regression model. And we will import some metrics. So from the metrics, we'll import the accuracy score. So you can just write this line by line using this enter. And once you want to execute this thing, so you will use this shift enter. So this will say that, okay, so there is some, yeah, there is an error in this accuracy. Yeah. So we have imported the dependencies. So now we will the data we have. So our next step is this. We have to process this data, and we have to this data collection and data processing. So here we will do. So we will get a CSV file. We will read this CSV file. So our first thing is, so we know that in Python, if we use this hash, so it will just convert a command into a code into a command. So what we'll do, we have to load this data, the loaded the data frame, this data set into a Python, this pandas data frame. So we are importing these pandas because these pandas actually there are many data frames, and this panda is actually used to this pre-process the data that we have, this raw data. So we are loading the data set into pandas data frame. So we are giving a variable name that is a sonar data. And we want to use this panda, this PD, since we have write this input pandas as PD. And this is the function that's the read underscore CSV. So now we will give over here. So here we have to give this path of this, the CSV file we have. So we will do that. We will just go over here and click on these dots, 3 vertical dots, and here we get this copy path. And you give this copy path over here. And since we have this no header, so we will give this header as none. Okay. Now, if we want to see this first 5 rows of this data file, so we can just First 5 of the rows. So we will do this. Sorry. So not data. So this will print this first 5 rows you can see over here. So here is this from this 0 to this, we have this 59, means there are 60 columns. There are 60 features over there spanning across this 60 columns. And in the last one, you can see, so these are the labels, this 60th column. So this means there are 61 column over here. So that is that it will print this. So this sonar data.h, so it will print the first 5 rows of the the data set. So now we need to know the how many number of columns and how many number of rows are there in the set. Find the number of rows and columns. So anyone having any type of doubt, so you can interrupt me at any time, and you can just unmute your audio and ask me any question. So you have to know this number of the number of rows and columns. For that, we will see that use that sonar underscore data shape. So it will just no, there will be no this parenthesis. Yeah. So that is a 208 rows and 61 columns we have. So this tells the shape and the size of the data set. So it is a very small data set, you can see. So machine learning algorithms and most of this practical real time, you will see that thousands and lakhs of data there. But actually for our experimental, for this coding purpose and for this initial purpose, we are going with this small data set. So now, so we have find this is a 208 of number of columns, these rows, and 61 columns. And at this moment, we want to calculate some of the statistical measurement of the data, such as standard deviation or the mean, these parameters. So for that, we will see. So we want to calculate the statistical. We'll use here sonar data. So this dot describe. So these are the sum of the values. So you can the count is 208. We know that. So this is the mean of all this 59, the 60 columns we have. The mean value of this particular the 208 point of the standard deviation, the mean and the max value, and they have this 25 percentile, 50 percentile, and 75 percentile. These are the statistical values. And this we know the standard deviation mean of this, and this 25 percentile and 50 percentile. This stands for that in the total data set, it's 25% of the values are this value or below this data set. Similarly, for the 50 percentile, so 50% of the values of the total data set are either have this value or below this. So this stands for this 28 percentile, 50 percentile, and 75 percentile. So we got this statistical measurement from this data. We have this value with us. And the most important thing is that we want to calculate how many rocks and how many mines are there. So the number of rocks and mines. Actually, we have this label with us. This one is there is no this. Yes, these are the labels at the 61st column. You can see. So it is a 61st means we are starting from 0. So it's from this. It will be 61st column. So number of the rocks and mines. For that, we will use this sonar data. We will tell that at the 60th column, we have this value. We have this label. I could count the number of. So here we have this number of this mines is 111 and number of rocks is 97. So we can say it is more or less this binary. We can tell this is binary classification. This more or less the number of this is around this 100. So we get this number of these mines and number of these rocks, and we will calculate the mean values of this rock and mines. So next we will calculate the mean values of rocks and mines. And for that we will do this sonar data the mean value. So these are the main values of the mines and the mean values of the rock. So you can see for all the columns you can see over here. Okay. So at this moment we have this total data set. In the total data set that you can see, in the total data set that we have seen that we have this all the features as well as the level. So this is the feature. So this 0 to this column up to 59, these are the features, and these are the levels. Means which one is rock and which one is mine. So we can understand from the level. So what we do, we have to separate this data and the levels at this moment. So our next is the separating the data and levels, whether it is a rock or mine. So we will do this in this way. So we'll define two variables. X is the sonar data. Come to this so this is the thing. So what happens is sonar data drop. So in this X axis, we will do this X column. So we'll drop this column number 60. Those are the levels. So we are dropping this levels over there in this X column. Except the levels, we have this data in the X, and axis is 1. So this axis contains two values. Since we are defining this column over here, so the axis will be 1, and for rows it will be 2. If we are dropping any row from this using this X, so that the axis will be 2 in that case. And in the Y variable, we will have this levels. Okay. There is some let me check. Sonar data drop columns. So it is a columns here. Yeah. Okay. So you have to check this while writing. Just this. It will be there. There is no argument with column name, but it is columns and plural. Yeah. So now we want to print this two variables. Print Y. Let's check that. Okay. So you can see these values over here in the X column, 0 to 207. We have all the values, the features over here. And in the Y column, we have only the labels over here. These are the labels. So we have separated this data set into data and the tables. And now we want to split the data into training data and the test data. So our next, this title will be training and test data, splitting this data. So we will create this 4 variables: xtrain, xtrain, xtest, ytrain, ytest. These are the 4 variables. And now we have used this, we have already imported this actually, this train test split over here. So we'll use this train test split. So our the first this input arguments, our first initial the old data, and here we are mentioning the test size. So we are giving this test size as 0.1. 0.1 means 10% of all this total data set. So this 10% of the total data set will be the test size, and the remaining 90% will belongs to this training set, the training set. Now we will use this stratify y. We will stratify the y. Stratify, and I'm coming to this. Why I'm using this stratify and the random state. So random state is 1. Stratify is this. We have stratified the y because to keep the distinction, because we have these 2 data over here, this rock and the mine, and we want to keep this in this y train and the y test. And suppose if we don't this stratify, use this stratify, it may go this the x train. In case of x train, all the a rock this value goes to this x train and the mine value go to this x test. It may happen. So we are using this stratify equal to y for this, and random state is 1. So you can mention any random state. So this random state actually it maintains the reproducibility of the code. So suppose I am coding this, and anyone from you are using the same programming this code lines, and if you want to split the data in a similar way, just as I'm doing, so you can use this random state 1. So what it will do, it will just split the data in the same way that it has done in my system. So that is the specification of this random state. So thus we have defined this. Now we want to print x shape xtrain dot shape and x test dot shape. So the original we have this 20860. So in the training we have this 187 for the training set and 21 for the test set. So we have this 21 that data we have to test, and we will train our model with this total 187 data sets. So this is up to this point we have this. So now we will print the so also we can print this this x train. If we want to print this x train and the y train. So yes, now we will do what thing after this training and the splitting the data. Now we will model this our training data with this training data, and we have used this model, this logistic regression model. So our next model training, we have this logistic regression model with us. So we have used here this. So our model is, I've already imported this model, the logistic regression. So this is the model we will use. And now we will train this logistic regression model with our training data. Training the logistic regression model with training data. And we will just like this model.fit. We want to fit this X trend. So this will just, yeah. Now is it already that model has been completed. So training this, we have modeled our training data using this logistic regression model. Now we will see, since our model this, now we will see 1, 2, 3, this, what are the evaluated results of the model, how to do the model evaluation. So we will see our this, we have used all of this, we have used the trend test split, logistic regression. And now I want to see this accuracy score of the model that we have done. Okay. So this will be our next set of what is the first we will check our accuracy score on the training data, that the data we have trained, and then we will see with our test data. Means that thing is that no, this training and the test, what it happens actually, suppose we have an examination and the examination will be of 50 marks. But for that examination 50 marks, you will read some 10 to 15 chapters. These 10 to 15 chapters are the training data. So you have trained with various types of chapters and with all those things, and you got ready for this examination. And the test data, within these 15 chapters, you will get some not more than 10 questions. Since these 10 questions are the test data date. So that will determine that how we have studied. So this here also the same thing will happen. That we have modeled this using this logistic regression model. We have trained our model. We have trained our data with this model, and now we will see also test that. So whether it has passed or not. And actually, the passing criteria for our machine learning algorithm is more than 70%. If the accuracy is more than 70%, we can say that yes, the model works well. And just we will go through this one by one. So first we will do this training on this accuracy on the training data. So since we have this only this 208, so these are very few data points are there. So actually this less data points go through this less percentage of accuracy. The accuracy may be low in that case. And if we have this thousands or lakhs of data with you, so you will get much more higher accuracy with your training data. So now we have this accuracy data. So we will just get a variable extreme prediction. Okay. And we want to see the accuracy score. The accuracy score of our so we will see the accuracy score of our this trend prediction that we have done with the Y trend that has the levels already. So these are the comparative study we are doing. Okay. Yes, Ashutosh. So I will say this mail, this IP1B file. So it will be there, I suppose, in the website. You can get this file from there. So now we want to print this accuracy on training data. So here we will give this. Let's check the accuracy. Okay. Yeah. So the accuracy of the model is 83%. You can see on the training data. So we can say that it is a the model fits quite well over here. So that we have done our model evaluation on the training data only at first. So at this point we will check our accuracy on the test data. So now we will check our accuracy on test data. So we will use the same thing, this only, and we will just replace this train with the test. So there is the test data accuracy score. We want to check this X test prediction, and this will be similarly the Y underscore test. Print accuracy on test data. And we will just give this test data accuracy. So let's check this accuracy on the test data. Yes, Ashutosh, actually, I will send you and I will tell you this. You can do it in Google Colab only. And you can get the dataset. I will share the CSV file with you. And also you can get some dataset. I will discuss it later at the end of this class. I will just inform you everything about from where you can get the dataset and what type of data you can access and how you can do this training model training. And yes, so this the accuracy of the test data it is more than this 76%. So we can say that yes, this model has passed this examination and with the 75% marks, 76% marks. And so this is just we have gone through this. This is what we can say, that we have trained a model and we have also tested that model with that, and we have got this accuracy score, and the accuracy score is more than 75%. Now we want to make a system. Actually this thing is, we have to make a predictive system. We want to prediction whether it is a rock or a mine. We want to predict it. And how we want to predict it? If some input data is with us, from that input data only we have to determine whether this is a mine or this is a rock. So we will make a predictive system now. So our next thing is making a predictive system. Making a predictive system. So these are input data. Suppose this is input data, and this input data is in the form of a list. So I will go back to this data set, actually this Excel data. Just hold on. Let's finish with the code. So this is the input data. So it's the input data in the form of a list, and we have used this NumPy. So NumPy, this beauty of this NumPy, this anything you give to it, so it will just give the output in the form of an array. So we want to convert this data set in the form of an array. So what we'll do, this changing the input data to NumPy. So we will do this input underscore as NumPy array, this NP as array of this input data, And since you want to predict, so you have this 208 of data. Suppose we have this 208 of this data with me. So I'm going to the Excel sheet, Excel file. Just hold on. So this is the basic raw data file. Except this last column, we have this PHS with us. So we are dealing with this 208 column. But if we want to take particular a one instance, suppose this column one, row one or row two, any of the above, just like this. So for that we have to convert this NP array or the NumPy array for one instance. We have to convert that, since the dataset will determine only for the 208 data points. But we want to check that for a particular any one of the features, this row, but any one of the rows. So we have to convert this NP array for one instance. So we have to reshape that array. So how we will do that? So that will be our next step. Yes. Yeah. So input data is this. So you are changing this input data to the NumPy array, and now we will reshape NP array for one instance. How to do that? So we'll just input data. So we want to convert this NP the input data as NumPy array. So this is this one and minus one. So this is the range of the value. So one of the prediction will be created variable, this prediction, the model dot predict of this particular input data reshaped data. That is the want to predict. So this is the final output. So now we have this with us. So now let's check. So let's open this. Just wait for it. Let's wait for it. I'm coming back to you. Yes. So I'm sharing this. So see, this is the data in this Wattpad. So these are the 59 columns you can see. These are the data, and the last one is the level. So I'm randomly taking any one of this out of this 208 data. Suppose I'm taking this. Okay. I'm copying this file, and I'm going back to this. This over here in our code, and I'm pasting this data in the input data. You can see. Okay. So we want to now we have to print the prediction. Let's check. So you can see that when we print the prediction, it is coming as M, and that data was of a mine. So it can predict that whether through this data, so whether this data is a mine or a rock. We can again take any other data, suppose any other data we can take. Let's check. So any of this data. Yeah, let's take this data. Yeah, so we can just go over here and just paste this new data, and let's print the prediction. It's not an aim. Okay, so let's copy paste one more time. Copy paste. But it is not promised R. Okay, let's check it. Yeah. I will surely go to this. This is actually what happens. So you have to just be careful about a little more of it. Suppose. So we can. Yeah. So actually, this is there. Since there are two things, this rock and the mines. So we can do one thing over here. We can use this conditional statement. So actually, you can see this element what you are getting. This element. This is a list actually within this third bracket. So this is a list. So what we will do, we will use a conditional statement. That's if our prediction at the first element. So this is an index in the list. All the elements will be determined to the index. So if the prediction at the index 0 means this position is equal to this. Suppose I have given this rock. Will print the object is a rock, or else there will be a colon over here. Else we can print object is a mine. So in this case, we just see through the output. So you can see that when I run this conditional statement, the object is minor. So it will just go with this and you will get the following output. So using this one instance, this predicts this. We are making a predict system over here. So using this one instance, you can also determine the whether this is through this model. After training to this model, you have get this model. So you can determine whether this one instance is a rock or a mine. And this you can also this you can do what thing. You can also you save this in copy in a drive, or you save this copy in a GitHub gist. So that is this rock versus mine prediction. So I will share this this IP1B file to you once the workshop is complete. So this is our one model. So we have used this logistic regression model, and you can see there is a binary classification problem. So we have this either determine this rock and mine. So next yes, our next will be this. We will go to the next program. Let's see the next program we have. This our next project. So this is so that is our ultimate expression. You can see from this slide. So you have this new data. You have to determine whether it is a rock or mine. You have to predict to this. So we have got this logistic regression model, and we have trained this logistic regression model. So our next program is this diabetes prediction. So it is a healthcare problem. So you know that this in these days there's a healthcare has got this massive attention after this pandemic, and this AI community and the machine learning community is working. This all of the big giants are working, particularly in the health data. So we need to learn. We will see a project using this data. So this is the diabetes prediction using this machine learning, and we have used this Python and the support vector machine. So that the algorithm we have used. So we will first see what is a support vector machine. We will not go into this sort of this mathematical derivation or theoretical jargons. We will see only simple thing. The support vector machine, actually, it is one of the most popular supervised learning machine. So what it's actually do, we have seen in the first our this preliminary workshop, that is on November, this concepts on machine learning. So what we have defined this, you can see that there is a line over here. This is the hyperplane. Actually, this is a margin, you can see. And on the margin on this the support vector machine actually does there is this two positive sides on this two positive plane. There's two hyperplanes on both sides of the margin, and one is this positive hyperplane, that is this above the margin, and below the margin you have this negative hyperplane. So our in our study we will see that this to this diabetes prediction. So we will categorize the data set into a diabetic and a non-diabetic. And for that particular reason, we are using this support vector machine algorithm, this SVM classifier actually. So it will place the data over this or on this negative hyperplane, or either on the positive hyperplane or on the negative hyperplane. Now let's check the workflow of this particular. So you can say this diabetes data, this input data, we are going through this pre-processing. The same thing more or less. The workflow means the algorithmic structure of what we'll do with this, how to train this model. So this remains the same, but the difference is the SVM classifier that we will use over here, and we will got this SVM classifier through this train test data. We will split that data, and with this train support vector machine classifier, we will go to this. We will feed this new data, new test data, and we will find whether it is a diabetic or non-diabetic case. So that is the thing. So we will see the difference and what type of this libraries we need to install or import from. In this case, we will see now. So let's go back to this Google Colab. So we have this new project. First we will connect, and this is our project 2 of the day. So this is a diabetes prediction. That is our first one. So now after that we will go with this diabetes data we have. So we will upload directly over here our diabetes data. So I will send this CSV file to you through this link. It will be uploaded in the link. You can download it from there. So I have connected to the Google Cloud, and we have this. Yeah. So Ashutosh, I will send you at this end of this lecture. Okay. So we have this the first thing. Yeah, it's okay. Yeah. So there is a thing, our importing our dependencies. We will see what we have to import. So initially we have to import this numpy as np, pandas as pd, and we will sklearn. We will this pre-processing of this data. We have, since we have this, why we will use this pre-processing sklearn, we have to import this standard scalar. Standard scalar, yes. And from sklearn also we will import this model underscore selection, train test split, that, and we will import our SVM, our support vector machine model, and sklearn we will import matrix. That is we will import the accuracy score. So these are the files that we need. So you will get this data set. Actually, now coming to the data set points, that we have this CSV file and all this sonar data file. Actually, these are these data sets. These are all well established data sets, and most of the data sets you can found from Kaggle. If time persists, I will today will let you this show you that how you can get the data set from Kaggle. And most of the data sets that you will see in this Kaggle, this is very popular website. It is from, I suppose it's 2010. So it is a very popular site. So from the Kaggle, you can get this. These data sets are actually either of some international MNCs or these MNCs or some research labs. So they are very genuine data sets. So these are the actual data, and these data are in range of this 50-60 GB. So since most of us have done this luxury of this using this a super class workstation, so Google Colab in that case you can use it. So it can just just you can see for our experimental purpose we are using this small data sets. And another this thing the thing is that is Google Colab. We have this, you have heard of this Jupyter notebook. So this Jupyter notebook, you can also this download that in Jupyter in your machine, and you can just go through this this IPYNB file. And I will let you show later that how you in Kaggle you can get data sets. This Kaggle is actually very important platform for this machine learning. Okay, so what we know that actually there are many competitions in Kaggle. So you will find some data from 2011-12 that time also. So even if you practice with those data of this 2011-2012, so you will get to know that, and you will also find in the Kaggle that many users have uploaded their own model. So you can use that also. That is also a good way of learning. So now come to this project. So diabetes prediction. So we have imported this this NumPy pandan from the scalar, and we have imported the standard scalar. So this since the standard scalar, actually this we will see that in this data file once you see. So there are many types of data. So the insulin level, the glucose level, the BMI, actually, and this data is particularly belongs to a particular section of this pregnant woman. So we will see just let me check this data. So our next work is our data collection and analysis. Okay. And we will just, so yes, it's a PIMA diabetes data set. Now we are loading this data set. The pandas data frame, as I have done before. So we are creating a diabetes data set. Where is this panda? Read underscore CSV. Okay. So this is our file. We'll copy path and over here. Now, if you want to print this, some 5 rows of the data set. We will use this diabetes data set dot it. So here you can see these different types of these attributes: pregnancies, glucose, blood pressure, skin thickness, insulin, BMI, so diabetes pedigree, function, and the age. So these are all the features. So these are all the features. This 1, 2, 3, 4, 5, 6, 7, 8 columns and features. And here you can see the outcome, this 1 and 0. So in case of this 1, this particular patient is diabetic, and for the 0 it is non-diabetic. So that is the outcome. So these are the labels. At the last column you see these are the labels, and these are all the features. So we will use this scalar to we are using this standard scalar you have seen, the standard scalar for these different attributes only. So we will get to know what it will do. Okay, so now we have this number of rows and columns in the data set. So we have this diabetes check. From there we can learn this. What are the number of rows in data? Yeah, so there's a 768 rows and 9 columns are there. So the 9 columns. So the last column is the label, and the remaining 8 columns are the feature, consist of the features. So similarly, we will get this statistical measurement. The statistical measures of the data set that we have. Diabetes data set. Let's code this. Yeah. So these are the 760 data points, and we have this statistical value with us. So we need this statistical value, this point. Now we will find, after the statistic got, so we'll find the number of patients actually. So how many are this diabetic and non-diabetic? And we will get this value only from this outcome. This outcome we can get. So what we will do, we'll use this diabetes. Let's check this. Number of diabetic and non-diabetic. So the thing will be diabetes. Yeah, data set. So we want to this outcome from the labels we'll get over here. Value underscore counts. Okay, so this 500 is this non-diabetic and 268 is the diabetic. So number of this data, 268 data are diabetic and 500 number of data are non-diabetic. So we'll get this classification. So we can just have some idea, otherwise it may create a problem. Non-diabetic and 1. Now we need to find the mean of this. Okay. The mean of this. So I've calculated also before the data set by so this is the we'll calculate the mean from here. Now this now since we have this where it is so since the 9 columns, and in this 9 columns we have these features in these 8 columns, and the last column is the outcome. So we have to separate these features and the data and the labels at first. So this is our preliminary job before training this data. So we'll just separating data and we want to create these 2 variables, x diabetes data set, and we will drop the last column, that is the output, is the outcome, and we will give this axis equal to 1. I mentioned before that for row it is axis equal to 2, and the y is another. So here we will consider this outcome. We'll take the outcome column in this y. Okay, Now we have to print x, print y. So you can see that. So this is the x with all the features, and this is the outcome. That is the levels from 1 to 7, 6, 8. So now there is a problem that we have these various types of data with us. So this glucose level. So you can see this range of this data is too wide ranging. So if we input this data to our model, it will not work. So before that things, we have to need some further processing. So the next thing is that we have to do the data standardization. Now, why standardization is required? So that we can get the data in the same range. So it will be this, you can say it's one type of optimization problem for the machine learning algorithm, so that the algorithm can understand the data and it can predict the data set. It can correctly predict from that data set. So so in this model, so we will see how to do a data standardization. And for that only we have used this scalar, that the standard scalar we have used. So that is for this only. So see this data standardization. Okay. So now we have defined this variable scalar, and this is a standard scalar. We have called this function. So you can see that we have already done over here the standard scalar. Scalar fit. We want to standard using the scalar. We want to fit this our x value, that the features over here. Now, what we'll do, we will use this. We want to get the data in the same range. So we are using this standardized this variable. This standardized data is a variable name, and we want to transform that. Our x value, that is the features that in this. And to print this standardized data. Okay. Now we can see the values over here. So this is the x we have now, this in this x we have this standardized value. So we will define in this way. So the x we have this standardized data. This is a new variable. So and y we kept the outcome. Okay. We want to print this x and print y. So this you can see to the x and the y. This is the standardized data. So we have this standardized data now. So we have now we will, if we get this into our machine learning, so the machine learning algorithm, this model will recognize this data. So we have done this standardization, and for that standardization we need this particular standard scalar, this module from the scalar. So now we have done this, that data processing has been complete. So now our next step is to train this splitting the data into train and test data. So we'll just try this train test splitting. Okay. We'll create these values X train, X test, Y train, Y test, and since we have used this train test split, we'll just go from here. In this, we have our this value, this X and Y, the test size. So since we have some this data size is quite few, so we will take this 0.2. So it is quite large than the previous one. So we are taking this 20% for this test data. And similarly, we will this stratify Y. And now we can use this random state as 2. You can use also it as 1. That is not an issue. So if you use this at 2, so it will the data will split according the same in a similar way in as it is done in as is doing in my own system. So we have this now we have this trend test data. We have splitted this, and we want to print the shape of this. We want to see that how many data there in the trend and the test. So it is this is quite fine. So we have this test, we have this for 154, and for this we have this was 614 for the training one. So we have completed the So now we have this, we will now train the model. So I've completed the train, this splitting of this data into train and the test data. So now we will go to the model. So we will train our data with this model of the SVM. Training the model. So we have this new variable, that is a classifier. We have used this SVM from that import that we have import this SVM support vector machine, and we have this support vector classifier SVC, and we will define the kernel since it is a linear one. So we will just we'll mention it as a linear, our SVM. Now we have defined the variable, and now we will train the support vector machine classifier. Okay. So what is this? This is an easy step. So we will just classifier dot fit our X train and the Y train. So that is, we have done this. So I have trained the data using our support vector machine classifier. Now we'll be able to do this model evaluation. We will see the accuracy first on our training data, next on our test data. So we have this model evaluation. So first we will see this accuracy on the accuracy score. We will calculate first on this training data. Now we'll create a variable, it's the X train prediction, and we use this classifier.predict from the X train, that value we have, and our training data accuracy we will calculate from this our the predicted data with the Y train, that is with the outcome. Accuracy score of this X train, that is this one. We can just do this one thing. this X-trend prediction, this one, and the Y-trend, just like this. Just sorry. Okay, classifier. Yeah. Okay. Now we'll print this accuracy score of the training data. Ashutosh, can you explain which part, which one you want to know? We are calculating this accuracy on the training data. So what we are doing, so we have defined this variable, this X trend prediction, and with this we have defined this classifier, and in the input we have given this X trend. So from that it will predict. Yes, I'm just going through that. So and this training data accuracy, what the accuracy score will do, we have this X trend prediction, and it will compare with the value of the Y trend, because in the Y trend we have this outcome already we have, and we are comparing this X trend prediction with that particular Y trend. That is the thing. And with that, it is a comparative study. So with our we have this training prediction. We have this. I can say, yeah, this one with our this Y trend, and the output we will just give this value. This in the print we will see this training data accuracy over here. Now you can see that this our accuracy is 78.6%. So the data that we have trained through the features, when it is getting in compared with the Y trend. So how much it is recognizing? It is recognizing 78.6% of that Y trend data. And that is the accuracy score of our training data when compared with that with this Y trend. So actually that we have the training data, this training data we have split. So first we have splitted it into train and test. And with this training data, we are doing this, we are calculating the accuracy first of all, and then we will go to this accuracy score on the test data. We will go print the same function, and we will just this will be on the test one, that the 20% that we have splitted before. Yeah, X trend prediction, X test. Okay, and now we will print the accuracy on the test data accuracy. So it is nearly coming about 77.2%. So actually this is a close value. You can see the 78 and 77. So that data has recognized well this. So we can say that yes, the model has worked well in our case with this data. So this completes this part of the training and the test data. So we have measured this accuracy. Now we will again maintain that of this predictive systems. Now, how to do with a single instance, if you are given a single list, or something, a single instance value of a particular feature you have. So from that you have to make a prediction of whether the patient is diabetic or non-diabetic. So now we will make that predictive system. A predictive system. Now we have this input underscore data. Okay. Similarly, since it will return as in the form of a list, we have this data. So we will do that we will change this input data changing the input of data to numpy input data as numpy array. So we are converting this, changing this data we have converted this list actually to an array using this numpy model. And since we will go for this only, as previously we have seen this, we only go for this one instance. So we have to change the sense. So that model is actually fitted for the 768 points, data points you have, 768 data points. And also this training data on 614 data points and the test data on the 154 data points. The total will be 760 data points. So we just want to identify this system that if it got a single instance. So for that we have to change this, reshape this array for predicting one instance. So predicting for one instance. So here you can see that you can also this input data not required actually. Want to this one now you want to reshape it, and you want to give this boundary that the reshape function with 1 of -1. Now so one thing that in our data we have this different attributes, as you can see. So if the input data that we are using this in the prediction system, so predictive system. So similarly, we have this instance where we have many attributes at a single in a single list. So what we have to do, we have to use this standardize this input data here also. So our next job is to standardize the input data. Okay. So now we have created the new variable, this standard data, and we have use this scalar as I've done before. We have to transform this reshape data. Okay, we have to convert this reshape data and to print this standard data. Okay, now we want to make this prediction, and how we will predict it from this variable that I did, the classifier.predict of this standard data, this one. So it will predict from this standard data, standardized data actually, std data. So we want to print prediction. So before that, we have to give any input array over here, input data. So what we will do that, I will check as before. We have this. Suppose I'm taking any of the data sets from this. So what you can do that you can go to this CSV file that is with you, and you can convert it into and open it with a notepad or Wattpad and select only one instance, just like this, without the outcome. So these are the values of this 8 column you have, and without the outcome you have to go for that. And this data is a particularly of just check once more. Yeah, so this is a data of diabetic patients. So now let's check. So this is the thing that you have seen. Okay, there is some issue. So this is the prediction that you see. This is the value of the print, the standard data, the standardized data over here. And let's check this. We have this some sort of let's check it. Okay, NP as an input data. We have the input data reshaped. Yes, this reshaped position. NumPy array. Yes. Now we have the standard data and the input data reshaped. Some check. Let me see that there is, you can see that there is this line, there's a skill on base 41. X does not have valid features name, but standard scalar was fitted. So I've used this scalar before also. Okay. If you can find any of this why this error is coming, you can also notify me. At this point, I am trying to find it actually. Let's go back to the previous one where you have used this X, okay, which is called. Yes, that has been done. Changing the input data as the NumPy array, NP as array input data. We have given this, yeah, and the input data reshape. Yes, we have given this input data as NumPy array reshape 1 minus 1, and we have, when standardizing the data, we have given the standard data, and we have transformed this data, the input data of this. Yes, we have this input reshape data. We have standardizing data with this scalar dot transform is fine. And after that, we have this print. Yeah, we have this standardized data. We are going to print that. So this happens to be the standardized data with me. And now we want to predict this classifier dot predict with this standard data. I think there is some issue. I don't find any error over here, but I don't know why it is happening. This is clashing with the, maybe it is clashing with this X feature, this data. So actually the idea is to think. So at this moment, I'm not wasting in time behind this, because this is not some syntax or the logical error, because there's no logic in error. Any exception handling is not there, exceptional error. So what is this thing? The predictive system, it will just okay, let me check with another input data at this moment. Check this. Okay, So I hope that if there is any question at this point, you may ask me. So the thing is that actually at this moment, there is some issue with this particular code. So it will just in this print prediction, when I'm getting this input data, any of the input data that you are seeing over here. So if you can just, you can get this from the notepad. So if it, so at the outcome, at the out level, you will see whether it is a diabetic or a non-diabetic patient. So what you can do, just get one instance over here. So what will print? So I have taken this data, it is of a non-diabetic patient. So the output in the when I'm this printing this prediction, so it will show that just it will just print it as the person is a non-diabetic. This it will at this point it will show this what I'm getting in this form of this. Yeah, yeah. So it will just print at 0. Yeah, actually it is coming as 0. You can see this is a single list. Okay, let me check with another one. I'm going with a diabetic patient now. Yeah. So you can see the output, but I don't know what is this. Yeah. So this is of a diabetic one. This is a non-diabetic one. So you can see that this is 0. This value is coming 0. So you just leave this at this moment and just concentrate on this list. So what we can do, this print prediction. So here you can see this output is in the form of a list. So and it is the index 0. So what we can do, we can similarly we can do a conditional statement over here. That if this prediction at the index 0 is 0, we want to print the person is not diabetic. And else, so we have this notation over here, print the person is diabetic. So when you will run this, so you can see this belongs to a data of non-diabetic. So this is a 0. And you can see the output, the person is non-diabetic over here. So this is the, you can say that this actually with one instance, we can predict through this system that whether the person, whether the system, the data is from a diabetic one or is non-diabetic one. Okay, so here is the thing is that from this initial point, you can see that we have imported the dependencies and we have done some this data analysis, how to data collected, we have collected the data. And here the main thing is, since we have this too many attributes over here and with different range of values, and it is quite it is broad range of values are there. So what we will do after this statistical measure and this splitting of this data and the labels. So our main function will this data standardization. So that is one of the this important thing in using this SVM, this standard scalar. We have to standardize the data, and after that only you will just train this model and using this SVM classifier. So that is the main thing over here. So you can find this is the whole thing. And this up to this we can after that, after training the model, we have to need this model evaluation. And in the evaluation, this since is a classification problem, so we will calculate the accuracy score. So this accuracy score on the training data and as well as the accuracy score on the test data. If the accuracy score is beyond this 70 or 75%, so we can say that data is working well and the model fits well with the data. So that inference we can draw. So always remember that we have some lacks and this lacks of data in this CSV file. Actually, this diabetes, this original data is nearly around this 60 GB, what I believe, this is around 60 or 70 GB data. So there are lakhs of thousands and lakhs of data there. So you can, in that case, you may find that this accuracy maybe greater than 80% or 85% in that case. So the inference, the conclusion is that with more number of data, the accuracy score also goes up. Okay. So this is our second program, the project 2 of today. And we will go to the new program. I'm just sharing the screen with my, this is the last program of today. That is the house price prediction using this machine learning. And we'll use this Python and XGBoost regression model. And this is a particular problem of regression. So the previous two, we have used this classifier model. Classification. So classification, the output, we know that the output is either of a male, female, true, false. Most of this is binary classification, and that is the one of the most important problem in machine learning. So here you will see that this regression model. So now our next determination of this regression model, and the regression model, we need some continuous variable, either the price or the salary or the age or just like that. So this is this Boston house price data set. So it is one of this. Boston is a city in United States, you know that, and there's a very posh locality in Massachusetts. It's behind this MIT and Harvard in that area. So we are getting that this area from this UCI machine learning repository, and you see that that the data was collected in 1978, and we have some this 506 entries with these 14 features. And if we get to this data, get to this data point, so you can see that there are various things. This CRIN, this is this criminal occurrence in that area. ZN means the zone. NOx is the nitrous oxide, means the pollutants in that particular area. What are the age of these people living in that area? The tax. This LSTAT is the lower level of this, that people who have some lower income in that that statistics. And finally, the outcome is the price. So that is our point of understanding. So what will be the price of a particular area we will want to predict. And since we in this regression model, so we don't have any case of this true or false or male or female or diabetic or non-diabetic. So the regression model, actually regression it is predicting a quantity and a continuous variable. So we will get all numerical values. And we have calculated the accuracy score in our case for the classifier problem. But here we will calculate some of the statistical value, such as the R-square value or the mean absolute error value. And from that, we will see that whether our data fits with the model. And XGBoost is a particular class of regression. And XGBoost has also this classifier and regressor. They both are there. So we will use the XGBoost regressor. This is a decision tree. So what I've mentioned, this is a decision tree model actually. And this is used to this ensemble learning. There's an example of this XGBoost, an example of ensemble learning. Means here you can do what you can do, that 2-3 models you can incorporate in one single model. Okay, so that is the decision tree model. And next we will see this workflow, how it is happening. So here you see the house price data at the input. We are doing some data pre-processing over here. And there is a particular thing of data analysis. And we will see this data analysis with this correlated data. And in this data analysis, we'll see that how the data are correlated. And we are to understand this correlation among the various features. Actually, you can see these features. These are the features. Leave aside this price column. And these are all the features. I have to find this correlation. And after that, this correlation will this split the data. And this, you can see that XGBoost, this regressor works the decision tree model. And finally, we will train this data using this XGBoost regressor. And finally, the data evaluation is coming over here. So we will go like that. So that these are the process steps. And we will just load this data set from this sklearn. We have this data set in sklearn already. So we don't need any type of CSV file or any external file in this moment. So let's go to this Example. At this moment, any one of you, do you have any question? You can ask me any question, any type of doubt. I will just send this IP.YB file at this. So I will just send. You will get all these files in the uploaded section. It will be uploaded in this website. You can find it from there also. I will also give you that cs.csv file. Okay. So are you this just one thing to know? Vigyan, Jibendu, Ashutosh, and Shushma, you are here. So I just want to know: are you getting what I'm what is being taught over here? Okay, okay, okay. So let's me this. If you have any problem in understanding, you can just ask me anytime. So that is our this is our thing. So this we have this Google Colab again. So this is the project 3, and this is a house price prediction. So our first instance is to connect. Yeah, connect to the Google server. So let's initialize it, and it will connect to the server. So our first step is we know that we have to import the dependencies that we have. Okay. NumPy as NP. We have to import this pandas as PD. And we will also see matplotlib over here that is used to plot matplotlib.pyplot as plt. Import the Seaborn library. This is a visualization library in Python. This Seaborn as SNS. We'll import this sklearn data sets. Now the same thing, just from sklearn we will import the trend test split. And we have used this XGBoost this regressor. So we will import the XGB regressor. Kindly be sure with your confirm with this uppercase and the lowercase letter. Otherwise, it will show some error. So we import the metrics. In this case, we don't want the accuracy score. So we will see what we will do with that. So what in terms except this accuracy score, what we will do. So this is the thing. So our next is we have imported these dependencies, the NumPy, the pandas, these two are for this array and the data frame data processing, and the matplotlib and the Seaborn. These two are the actually the visualization library you can see. And the final is sklearn. This sklearn is particular this for machine learning. So we can have any other workshop or any other class on this sklearn, because this will be an entirely new topic. And sklearn is one of the most widely used library in Python for machine learning. And this Google Colab and Jupyter notebook that we have used, these are all the basis of this is Python actually. So now the first thing we have to import the Boston house price data set. So this will be in the test. Yeah. So now we will just create this house price data set. This is so from this sklearn data set, we will just load this the file that we have. Okay, we can also this data set. Let's check this. If you want to print this house price data set, whether it can print. Let's check. Yeah. So these are the data sets that we have. Okay, so you can see that there are two types of things. This first one, you have this in the data set. You can see this data set. So we have the data and we have the target. So these data are the features. Okay, so these are the features up to this. These are all the features. And in the target, you will find the price of this. Okay, so we'll see the price of this, the price calculation, that is the levels in the target. And in data, we all have the features. So now we want to load this data set to a pandas data frame. So for we will data set to a pandas data frame. And for that, we will do one thing. House price data set. This is the house price data frame. We get this is a variable, you can see, and we just want to use this panda dot data frame. House price data set dot data. So we have this data over here. Just we want to get the data from this data set. That is the house price data set. So we'll also include a column over here, and with that, suppose if we not use this column, yeah, what happened? Okay, so this will be frame. Yeah. I've given this PD over here. Oh, okay. Sorry. Import pandas as PD. Yeah, that will be the thing. Import pandas as PD. You have defined this. Yeah. Just you have to run this once more and check through this model. Now we have to print this house price data set. I think that it will work in this at this point. Yeah, that is fine. So actually the problem is we have to just check once you have done some edit over here. So we have to interpret from this first position only. So that is the problem over. So now we have this this data frame. Now we want to print this first 5 rows. We have this idea from beforehand. So we want to print from this house price data frame dot head. So that is the thing. So this is the thing. You can see this 0, 1, 2, 3. So the headers are there. So we have this this different attributes over here, but it didn't get print. Why this is not, why this happened? Because we have not mentioned the columns over here. So now if we mention these columns, house price data set dot phr names. Now if you want to go with that, you just, so you can see this column over here. So with the inclusion of this, you can find this, the particular attributes that are associated with each column. So this is the all these data sets without this price column, that is the target, this target one. You can see the target is not here. So we have only went through this this data, only the data. Now we want to incorporate this target in the data frame. So how we will do that? So just house price data frame. So we want to include this price. Where it will get it from data set dot target. Okay. Now if we want to print first 5 rows, what we'll see. So you can see this and the difference over here. You can insert the price list over here. Now we have to find this the number of the rows and the columns in the data frame. You want to check. So check the number of rows and columns in the data frame. So how we will do this? We want to get the shape of this. That's as simple as that. The data frame dot shape. From that we will get the this. So let's sorry for that. So this is a 506. These rows are there, number of rows, and 14 is the number of columns. And this 14 with this, the 13 has these pages, and the last one, the 14th one, is the outcome. That is the label. Okay. Now, if we wish to see some of the missing values, we can also check it from the data set. So if any missing value is there, so we can also do this, check for missing values. So how we'll do that? House price, that the same thing, the data frame. So we will use this is null parameter. Okay. So we'll check if there is missing value. So you can see that with the sum. So the sum stands for how many missing values will be there. Any variable, that's null variable. So you can see there is no missing values as of now. So we can proceed from here. So we will just calculate some of the statistical measurement. Measures of the data set. Okay, the statistical measures. And this will be house price data frame. Okay, so we have this statistical value with us. We have this 506 data points we have, and we have the mean of this, all this data of that is the criminal per capita, this criminal uh, this zone also we have this out of this mean. So all of this data, so you can see in this 506 the number of counts. So we are getting this mean, standard value, the maximum, the minimum value, and all the percentile value, just like before we've done that. So this comprises the initial that this processing part, and we have told that we have to do some data analysis. So I will see that we have this various things. So it asks that this different attributes, as you can see. Let's take this. These are the things. So you can see these different attributes. And what is the thing? Main thing is that, so since we have this so many parameters and all the parameters are dependent on the particular price tag. So we want to find a correlation among this data, among these different attributes. So at this point, we want to understand the correlation between these various features in the data set. So this is our next title, that is we have to understanding the various features, understanding the correlation between various features. So at this point, we have to know this two things. So we have this positive data, positive correlation, and what is the negative correlation. So in the case of the positive correlation, it's if the value of this one of the parameter increases, so another value will also increase. And similarly, if it decreases, then it will decrease. That is just to straightforward proportional relationship. You can say this in the case of positive correlation. And in case of the negative correlation, if this if the value of one parameter is increasing, then the value of the other parameter will decrease. So that is this positive and the negative correlation. So let me negative correlation. So we have these two things. So now we will create one variable. Suppose there is a correlation, and we want to correlation this. We want to this house price data frame. This core function. Yeah, this is a correlated function. Okay, we have done this. Now after this, we have done this data frame we have correlated using this CORR. Now we will construct a heat map. And this heat map, it is used to finding the correlation among various columns. So what we will do, we will constructing a heat map to understand. So we will use this plot.figure. We will give some fixed size with this parameter 10, 10. Okay. And we will create this heat map using this seaborne that we have created. Since I have told you that is a visualization tool, and we will give some parameters. First one is a correlation parameter. There's the correlation, this variable that we have used. Now is the color bar, the C bar. So it is true. So the heat map, it will be the square in shape. So at the output, you will just get to know square equal to true. F empty. So this is a particular value of 0.1 F. We get to know. So the annotation, it is also true. The size of this annotation. So the size will be suppose 8. I'm giving over here. And finally the color map. So we want to give this color map as blues. Now check it. So this is the heat map you can see. So actually, what is this? What actually say? We will now define one by one. We will see. So we have first this correlation. So what this correlation? Actually, in this correlation variable, we have given this use this core function, this correlation function. So this heat map will first plot this correlation among these various variables. You can see. So the x and the y data, they are the same, and the c bar, that is, this is the bar, the color bar it will be. So this is true, and you can get this value of this point, this minus points minus 0.621. So the correlation is 1, means if the correlation is 1, so means it is following this the previous value. This the following value is this is correlated with the previous value, since it's a value of 1, and the negative value is no. That's the correlation is getting smaller. So here you can see this. So this FMT, this 0.1f. So this signifies how many digits you want to display after the decimal point. So here you can see this 0.1 means we have this point, this one significant digit after the decimal, one significant digit only there. So that is an annotation. So you have this true, and the size of is 8, and this color map is blues that we have used it. That's all. That is the thing of this heat map. Now, since we have made this heat map, and another thing you can see from this, you have to this from heat map, there is some this data analysis part. So this diagonal is just this of no importance, because it is going with the same value of this. You can see the correlation value of 1 means this the same attribute is getting overlapped over here. So that is the thing. And you can see this 0.9 with this means this is a positive correlation. That this is red. There is the radius of the area, or the area that you have defined, that you want to take and see this proportionality of the tax with this red. So as the tax increases, this red increases, with the tax will also increase. That is the thing. And you can see this L stat of this minus 0.7 with this price. So since this lower strata income, the people of this lower strata income usually over here. So you can see that the price has some negative correlation with this. Okay, you can see it clearly. Okay, so the more bluer of this, it is more getting correlated, and except this diagonal value, and the more you have this this lesser of this off white or white color, so it is more negatively correlated. So we are using this heat map only for that purpose. Yeah. Now that is our next part. So we have this train and the test data. So we have this data. So now we want to splitting. So the initially this data analysis part is over. So now we have this go for the splitting. Bring the data and the target. So we will house price data frame. So we want to keep that price in a different level. So this is we want to drop this price from here. Yeah. And axis equal to 1. And in the Y, we will store this house price data frame. We will keep this price over here. And we're going to print this X and Y. So this is the thing. So you can see over here that this is the X and this is the Y. So we have separated the data and the target. Getting the data into training data and test data. That is the thing. Similarly, we will create this as before, this X train, X test, Y train, Y test, and so here we use this, the trend test split from the sklearn. We have imported that. So this is the trend test split, you can see, and we'll give some value over here. So we want to give this test size of 20% and a random. We need not to stratify this because we don't have any this classification problem over here, and this is a purely regression problem. So we want to find predict a continuous value. So don't need no need of this stratifying this particular column. That is the outcome or the target column. So that is the thing. So this is the splitting the data, and we want to print the shape of this. So x dot shape, x trend dot shape, x test dot shape. So okay, so there is a dot. So you can see this this total is 506. In X trend we have this 404, and the 20% we have given. So X test we have this 102. So that is the process of the splitting the data. Now we will model this this training using this XGBoost regressor. So this XGBoost regressor that we mentioned before, this belongs to a decision tree algorithm, and this is especially of this part of the ensemble learning. So ensemble means you are this incorporating or this two or more models, okay, in a single thing. So I'm not going through this particular theoretical side now today, this because we are concentrating on this hands-on session, and more it is important to know how to train a data, how to use particular model. That is a more practical part. So, and the theory, be sure that you have to know the theory, because without understanding the theory, it is not possible to go forward or to derive something new. Because only once you understand the basic things, or only you this have some hands-on session or any this type of experience with your this all the established models, then only you can go for some new model, or you can derive new model from that only. So you need to have some this good experience in training a model, or is training a data set using your particular model. So now we are using this logistic regression. Suppose I'm giving you an example. So in the first, this rock and mine, we have given this logistic regression analysis. If we use this linear regression model over there, so what can happen? So that is a point of introspection, that you can see that you can use this linear regression model over there. Okay, so that is the thing. So in case of logistic regression, we are getting some accuracy score of 83%. So if you are using the same data set with the SVM model, or particularly if we are getting with this some suppose this any other model, particular any classification model, so we may get some other the accuracy score. And if it is better than this previous one, then we will consider that model only. So in this way, actually, this model is getting yes. Yeah. So this is you can we can check like that. We can get the accuracy score of that using this classifier model. So let's see what happens with our regression model over here. So now we will do some model training. First, when to train the model. So first is the model. We have this. We actually already imported that. So this is an XGB regressor. Okay. Just give me a sec. There is problem with my battery. Just hold on a sec. Okay. Yeah, it is fine now. Okay, there is an issue with the battery charger actually. So I've defined this model, load this model, XGB regressor. Now we want to train this model. With extra. So this model fit the same thing that we have used, this X-train previously. So we have this train the model with our data. And now we will go into this evaluation. So since we have this all numerical value at this point, so we were getting this numerical value, so we don't need any accuracy score over here. So rather we will calculate some of this statistical measurement. So one of them is the R-square error, and another one is the mean absolute error. So we will get this value from that, and if the value is close to this 1 or this unity, we can say that our model is our data fits well with the model. So it is well optimized. But if the value is greater than 10, so it will say that the data doesn't fit the model. So now we will have this evaluation, that is the prediction on that training data. So for that we have to prediction on the training data, and next we will see that the prediction on the test data. Okay. So now we have to create this a variable, this data dot prediction. We can see that, and we can just model dot predict X-train. Yes, and we want to print this training data prediction that we have done. Okay. So you can see the values over here. These are the prediction that we have. This price. These are the price of this value that the predicted price from the we have predicted through this X trend through the features. So we have predicted the price of this. So now we want to calculate the R square error and the mean absolute error from this our predicted data. There's a training data prediction as well as the this Y trend that in which we have this this particular value. This means the price. Okay. So this is the first one. So now we want to calculate this R squared error, and we'll mention one variable that is score underscore one. And this here you can see that we have import a matrix. This is the import. This is scalan. From scalan we have import the matrix. So we will create this matrix dot R2 underscore the score, and we will get this Y of trend and the so this one, this training data prediction. Okay. So that is the first one for the R square error. And we can also we will also calculate the mean absolute error actually, and the MAE, that is the short form. So we will calculate the score of here. So this is a matrix R. This R2 means R square error actually. This matrix dot mean absolute error. So there's the same this that we have used before. That is the X trend. Y trend prediction. Yeah. So I want to print this R squared error. Score 1, and similarly going to print mean absolute error. The score 2. Let's get printed. So you can see this value of this R square error and this R square error and the mean absolute error. So it is more or less this hovering around this point 1, the value of 1. So we can say that this value is nearly about this 1. So the correlation, there is a correlation among the data. So if we know that the previously absent, if the correlation is 1, then the two parameters are this perfectly correlated, positively correlated. So from here you can see that the mean square error and the R square error, they are getting this perfectly to this this value is near to 1. So we can say this model, this the training data that we have, this and the Y trend data there, they fits well in that. So we can also this do for this test data. You can also so now do this once for this test data prediction on the test data. So what we'll do, we'll just go over here this training the model with yes. Test data. Sorry. Test data prediction. X test. now we can also define the same expression of this matrix R2 underscore score, and we will this y test and the test data prediction. So this is the test data prediction. And similarly, we can underscore this the score of this two with the matrix of the main absolute error. We can just copy paste it from here. Yes, absolute error. So here in this case, it will be the y test, and it will be the test data prediction. Similarly, we can print this too. Okay. Let's check this. So here also you can see that this on the test data, the accuracy for prediction is the r squared error is near to 1, but in this case the mean square absolute error it is near to equaling to 2. So if it is nearer to 1, so it will just it will be much more. So we can say yes, we can say the model it's fitting, but we can if we can get this mean absolute error in this range of more close to 1, it will be much better. So now this we can also do one thing, that we can visualize it actually. Okay. So just this training data. So we can do here also that this visualizing actual prices and the predicted prices. Okay. We can write the code over here. This plt.scatter. So we will plot a scatter plot. So we are doing this y train and the training data set. Okay. And the training data prediction, we are going this the plot only for the trend data and the trend data prediction that we have there, and we can also label it, the x level and the y levels. Actual prices plt.y level predicted prices, and we can also give this title of this actual price versus predicted price. And sorry, so yeah, so we can see that I can also show function. So you can see this you can see this data. So this data is this more or less, this is a scatter plot actually. So you can see this scatter plot is more or less in correlated with the x level and the y level. You can see this is a perfectly showing a linear relationship. We can see that. So for this, suppose this actual price is 20 for some plot, so it is around this 20 for the predicted price also. So here you can see in this way, or and you can similarly you can do this same way of this in our test data. That is the test one. Yes, this one. So you have this test with this. and the test data prediction. So you can see that there's a difference between these two, this first one and the second one. So the training data is much more this correlated with this the price tag, but in case of this actual price and the predicted price for the test data, it is also this showing some sort of linear, but there are some scattering points. You can see that these 2 points. So suppose this we have actual price of 45, but it is predicted price we have this 39 or 38. So there may be, but in case of this area, you can see a quite good correlation between these models using our model of this regression, this XGBoost regression model. So yes, so this is the project 3 that we are using this regression model. Yeah, and the parameter over here is the R squared error parameter and the mean absolute error parameter. So we have to have this value is near about this 1, hovering around this point, this value 1. If it exceeds 5 or 10, then there is serious problem with the this with our model, with this model, with the model. So we have to be this be conscious of the, or be sure about it. So when you are getting this value, since this regression model actually, since it produces some value, so we have to this these are the parameters, these are the performance metrics parameter, you can say. Okay, so this will covers this 2 part of our this 3 projects that we have done today. One with the 2 with our this classifier project, this classification, the mine and the rock prediction, and as well as the diabetes prediction. That was there's a part of a healthcare project. And similarly, we have done this project on this house prediction, and it is using some regression model. So we have learned this how to implement this logistic regression model, as well as this support vector machine classifier model, and as this regression model, this XGBoost regression model, using these 3 examples. So I'm this. I'm just ending the sharing over here, screen sharing. So I want to know that if you have any question at this moment, you may kindly ask me any question, any doubt you have, it may be any question. Just don't think that it may be a just yeah. Yes, Abhigyan, I will just upload this. I will just give this meeting. Yes, the link of this IPYNB file. These 3 files. I will you will get these 3 files in the website also. So we will upload that surely. Along with that, we have this 2 CSV file, that the Excel file. I will also that provide you that file. So you just keep on. You can just try that with the same model, with the same thing, and you can also do something that you can also just go with your own model. Whether I'm using this, first try with the same model that I've used, and then you can also use your own model. This means any linear regression model in case of logistic regression, or so reinforcement learning. It is a different topic. This reinforcement learning is a different topic, means that will be a different case. We will see that later also. But okay. So tomorrow at the same time, we will join at this around 3 p.m. in this afternoon, and we will see some more models, and also see an exclusive program on quantum computing, this quantum machine learning, and we will try to find out if we can make some quantum neural network from there, and we will also see some of the this projects in using any other algorithms. Yeah, so this is the end of today's class. So today's lecture. So any question you can ask me, or you can just so is that fine? You can just unmute yourself and just speak out. There is no issue. Whether you've got this.
Yes, sir, got this. No doubt, sir.
Okay, yeah, you just must try it on your own. So I will share the files with it. I
Yeah,
will share
sure,
the
sure.
files. Yeah. Yeah, I will share the code Ashutosh and certificates. Surely you will get certificate for this workshop. You have to attend this tomorrow's session also. And we will learn some other things in tomorrow's session. Okay, Vigyan and Ashutosh and Muhammad Mohsin. So thank you. If you have any question, you can ask anytime or you can leave.
Thank you, sir.
Thank you, Muhammad Mohsin.